All right, we'll jump in. So I'm excited to talk with y'all today about building your AI data hub with Airbyte and MotherDuck. We're going to talk about what is an AI data hub. What do I mean when I say AI data hub? We'll talk about how to get data into your data hub. We'll talk about new features in AI directly available within SQL platforms. We'll focus on MotherDuck, and then we'll come back to some other platforms as well at the end. And we'll talk about what RAG looks like in the SQL world. If you've been following AI and you've been playing with tools like LangChain, OpenAI, you'll be familiar with RAG, Retrieval Augmented Generation. And we're going to bend the paradigm a little bit today. So, and then we'll wrap up with some warnings and best practices to make sure that you are successful. So, as Fraser mentioned, I've got some history in open source. I've been into open source, I believe, that for about 5 years now, open source data products specifically. Before that, I was in consulting, and before that, I was at some large companies like Amazon Video and EC2. So I just love building data products. So as AI has come on the scene, I've been really thrilled to incorporate data and AI together, and excited to talk to you about that today. All right, so let's talk about why you need an AI data hub and what does that actually mean. And let me say, before we touch these bullets, what I'm not trying to say. Your AI data hub will not replace every single AI tool that you have, and it won't meet every single use case. However, it would be the very first place you load your raw data. It would be your single source of truth for your cleansed and transformed data, and the place you go first for AI insights. So really leaning into your data hub as a resource for you regarding all the data that you care about. And really, the architecture that we'll talk about is really an evolution from data lake and data warehousing, adding AI and unstructured data to principles and practices that have been emerging in the industry in data lakes and warehouses. So what are we going to do with our AI data hub? Well, first, we're going to load it with data, as I mentioned, and that is critical. Depending on what kind of things you want to get out of your AI, it's not just spreadsheets and it's not just databases anymore. It's no longer that tabular structured data exclusively. You might want to take insights from New York Times headlines, or from your Slack history, from PDFs that you have, or from your company's Notion page. And you want to have all of that data available for inference, which we'll talk about a little bit later. RAG, Retrieval Augmented Generation. If you're new to RAG, the short way to think about that is just long-term memory, but specifically focused on taking large numbers of documents and making them findable quickly for an AI to use as context. As I mentioned, not just structured, but also unstructured data. And we're going to talk about prompting and aggregation as a key part of what you need to get out of your data hub. So we talked about ability to import data from anywhere. I'll talk about that a little bit more in a second. Other things that you want to look out for is make sure that your data hub has native support for vector data types. Those are going to be increasingly important. More and more databases do, and I'll talk about those towards the end. You'll also want to be able to do inline embedding and prompting. I'll show an example of that. Scaling up and down gracefully is really important. So this is where data lakes have become really popular. Tools like DuckDB, MotherDuck, Iceberg are really popular because you can bring your own compute, as I say right here, and it lowers your overall costs because the cost of storage is just in blob storage. And that's really critical so that when you're loading your next data source, you don't really have to think about the costs up front of loading or storing that data. You can just ask yourself, is this data valuable to me? If yes, let's load it. So as terms of division of labor, Airbyte will tackle these first two bullet points, and MotherDuck and DuckDB we'll talk about for the other ones in a second. So let's dive into Airbyte real quick. If you're new to Airbyte, there's a lot of features to love in Airbyte. Airbyte is underlying itself. It is an open source platform you can deploy anywhere. We have the ability to basically, you can self-deploy or you can use the cloud offering. And we also have PyAirbyte, which is a solution you can deploy anywhere. And automatic deduping is really core to our platform and also really valuable for vector stores, it turns out. Because if you have multiple pieces of data in your vector store, it can really hurt the quality of your data retrieval. I won't step through all of these features right now, but just know that like from the foundation up, we have these common sense features to help you be successful as you're replicating data from one system to another. the large number of sources and destinations we support enable you to be successful wherever you are pulling data from, and also building your own source if the source that you need is not available. We're built on a very large open source community, and as I mentioned, I'm really passionate about open source and really honored and humbled every time I see community contributors sending us a PR for something that they care about. So really excited to be part of the community here. Unstructured sources, we've talked about. We didn't really talk about vector destinations. And this is one of the things I've been working on a lot at Airbyte the last year and a half, is making sure that wherever you want to load data, you can load it to with Airbyte. So if that's Pinecone, Milvus, Vectera, Quadrant, or any of the vector store destinations that are most popular, you can do that with Airbyte, as well as traditional database destinations. And what we're going to talk about today is actually this third category of AI-enabled SQL destinations. Some people in the chat have asked what specific features in MotherDuck make it easy for AI teams to experiment. And I'm going to talk about that in a second. But just to tease, all of these platforms, these SQL platforms are adding vector capabilities as well as prompting and other cool AI features. All right, so let me do a quick demo for you, adding a custom data source. So this will be an Airbyte demo. We'll just spin over to Airbyte Cloud. This is running in my demo space. And you would have a similar workspace dedicated to you if you sign up on Airbyte Cloud or if you install and run locally on Kubernetes, however you'd like to run it. I'm going to just do a quick demo here and just show you how to set up a new connection. I've done this one a few times, but I'm just going to set up, let's do a GitHub source. All right. And what's nice about many of our connectors is that you can just use OAuth to complete the authentication. Now, that was really fast because I've been through the OAuth flow before, but what it did is just went through the GitHub authorization. And then I can just specify what repo I want to get data from. You could put in your own, if you manage a repo or if you follow a repo that you care about, you can put in your own repository here and then just set up the source. There's inline help if you're not sure. All right, so yeah, we can set up any number of repos here, but we'll just go ahead and set it up. So that's how to create a new source from the UI. You can do the same thing from PyAirbyte, and we will also show quickly how to build your own source. Let's let this run for a few more seconds. Actually, I'm gonna, in the interest of time, I'm gonna switch over now to the builder. Yeah, that's fine. I just want to walk you through the process. As part of this preparation for this presentation, I wanted to experiment with the Kaggle data set because I know a lot of people in the open source community are interested in open data and scientific data. So I went over here to our AI builder and our connector builder. I looked into the docs to figure out what the root 8 base URL was for Kaggle, and I started creating some streams. What's nice about this interface, I'm not going to go through every single part of it, but if you're interested in Kaggle, here's their website. And for my purposes, I just wanted to get a list of the data sets and the files associated with those data sets so I could get a better understanding of what free data might be out there that I could use for analytics. So I simply put the base URL here, specify how I should authenticate. I can add some streams here. Data sets is a stream that lists all the data sets. I can test it inline. All of this is a nice, friendly UI. It's all built on our connector development kit. And what I love is that you can actually see the code behind this. It's just YAML. And you can also get AI help if you need some help to build a connector. So just to show you, you can build your own source. That's really important to people at enterprises that have maybe internal API endpoints that they need to get data from, but also for people who just want to pull data and maybe that connector you want doesn't exist yet. You can also contribute it and push it back to our community, publishing it to your own workspace or contributing it to Airbyte. I've not pushed this one to the community yet to contribute to Airbyte, but I hope to do so by the end of the week. If you're interested in getting data from Kaggle, let me know, and we can talk about it. So switching back, that's basically how to get data from any source. If you're running PyAirbyte, you can actually take this YAML, directly copy and paste it into PyAirbyte, even without publishing, and then you can run the connector just with that YAML. All right. So now that's the sourcing part. Let's talk now about MotherDuck and DuckDB. So I mentioned and teased that vector data types are important. If you're new to vector types, the simplest way to think of that is just it's a fixed length array of numbers. So it might be 1,000 numbers that collectively describe a block of text. embeddings or vectors also can be used for different use cases like facial recognition and other applications also apply vector types. So we'll talk about that. MotherDuck and DuckDB have these built in, and I'll show basically some of these features as we go through. And what I'm really excited about that's emerging just in the past few months or the last 6 months is that more database platforms, including MotherDuck, are getting embedding and prompting capabilities built in. Meaning not only can you do vector search, but you can create those vectors or embed that text directly inside the SQL. And you can do prompting, aka you can ask AI questions directly within your SQL, and we'll show that as a demo as well. One thing to mention about Airbyte is you can deploy anywhere. I think I mentioned this already, but PyAirbyte is great if you want to just run your own Python code. It can run in a Jupyter notebook, basically anywhere, and then you have these options between OSS or hosted. So if you're new to DuckDB, I think you've probably gotten 5 introductions or 10 introductions just in this conference to DuckDB. Then here's one more introduction to DuckDB. And MotherDuck is basically serverless DuckDB++. That's not their term, that's mine. But you have the strength of DuckDB, but also hybrid execution. You can run some things in the cloud, some things locally. You have a nice web UI that you can go to and run queries directly. And so it's been super helpful for me as I create data applications. All right, and let's do a demo of that, and then we'll dive into more detail after the demo. All right, so here I am in MotherDuck, and I have a notebook open here. The first feature that I want to show in MotherDuck is actually one we haven't talked about yet, which is text to SQL. So if you are experienced in SQL, you maybe won't need this, but even I, who've been writing SQL for a very, very long time, really love this feature. So I can make this call and say, what are the top domains being shared on Hacker News? This is a native text to SQL function that MotherDuck supports. And I can get this query here. I can copy and put it in a new cell, and I can see it's doing some regex stuff against this table it found, checking that the URL is none, grouping by domain. And if I run this, it answers my question really well. Let me hide this. Yeah, so it says basically of Hacker News entries, I just know, okay, GitHub is the most common link. That makes sense. Then YouTube, that makes sense. Interesting that The Guardian is here and New York Times are popular links within Hacker News. So that's a cool insight. And I didn't have to write any SQL myself. You can go one step further if you really trust the system. Since I already know that MotherDuck can translate this, I can simply run this prompt query, and instead of spitting out let's see, what am I doing wrong here? Or did I just get bad luck? It wouldn't be a real demo if something didn't go wrong. So the difference between here, yeah, that looks like that was just a fluke. The difference between this is that we trust the system to just run the query that it defines, and I don't have to copy paste SQL at all. I just get the ranked domains just like I did before. What's great about this is then you can just inline change it up. Like, okay, I don't care about 4,000 domains ranked. I just want the top 10. So just by typing in the difference here, I'm getting live text to SQL results for some really interesting insights that I can get, that I can use. So that's cool. That's text to SQL. And then I want to show one more thing, which is inline prompting. So there's this thing called prompt, and think of this as like basically a call to OpenAI for every single row in my database, but without having to write any complicated code. So the question that I want to know is for everything in the Hacker News entry, what's its relevance for data science? What's its relevance for software development lifecycle? And what's its relevance for GenAI? So I phrase this question and I get back data that helps me, sorry, I've got my font set pretty large here, helps me understand the relevance of each one of these entries according to things that I care about. This is basically generating new data through inference using AI, and it's inline directly in my SQL. It can be incorporated into my dbt pipelines or anything else. And it's really easy to work with. Behind the scenes, this is using endpoints that guarantee a JSON output, and we're constraining the output to be exactly these columns and these types. So we're always going to get an integer back for all of these types. Yeah, so this can be really helpful. Like I could search this then for, okay, show me all the fives in all of these categories: data science, SDLC, and Gen AI relevance, and that could be helpful for me. So so yeah, that's just a quick demo of things that you can do. There's a lot more that you can do. I didn't show the RAG use case, but you can also directly do comparisons in SQL as well and get back your RAG most relevant answers. All right. So to recap, and also to talk a little bit more about those specific features I demoed, the SQL-based RAG, which I actually did not have a demo for, is super easy. So just type in embedding, that's the name of the function, and pass in some text, and you'll get a vector. Optionally, you can pass a second argument that says what embedding model you want. And there's a handful of models supported as of now. I don't know exactly which ones those are off the top of my head, but I know there are a couple different embedding models available out of box. Then for your RAG, you can simply take that vector you calculated, compare it with a new vector based on any question you want to send, and then limit the order to 15. So if you've used LangChain or if you've used other things like Pinecone, this is going to look similar and very different because in something like Pinecone, you're probably making an API call or a REST API call. You're not writing SQL for it. And so there's pros and cons of both. Pinecone and other tools that are purpose-driven for vectors are going to have maybe better indexing and maybe faster retrieval in a lot of use cases. But an advantage of SQL-based is I can just easily combine this or join this to other tables. And that would be almost impossible in a traditional RAG situation. So if I want to join this to another table that looks up by customer or finds limits by the top 10 customers that I have, those kinds of things are easy to do in SQL, but maybe not as easy or maybe not even feasible to do in a traditional RAG system. So here's the data hub architecture that we've more or less defined at this point. Some number of data sources, we get their raw data. We can use Airbyte for this part. And then from here, we can create document tables and vector tables that have the embeddings. We can use these vector tables directly for RAG use cases. We can create new inferences, like for Hacker News, where I ranked each article based on some columns that I was interested in understanding them better. People also use this for sentiment analysis, how positive or negative is the feedback. And we also have, just like normal, we have transform tables. So if you're using dbt to normalize your raw data and maybe clean up some data quality issues, you still have that process here as well. You're adding SQL-based RAG, SQL-based prompting, and text-to-SQL query capabilities. So my argument here is that this is a fantastic foundation to start with, no matter if you feel confident in AI or not. This is a great way to iterate. This is a great way to get started. And the barrier to entry has never been lower. So as I mentioned, there's some differences here. I'll just call out that text-to-SQL aggregations and lookups are super huge. That question where I asked, what are the top domains? RAG could never answer that because RAG doesn't work that way. It's not good at counting things or looking things up, but SQL is great at aggregates and it's great at lookups. So these are going to be a real strength for SQL. Yeah, we haven't talked about indexing, but you might get better performance out of a traditional vector index or vector store than you might out of SQL. And expect the SQL database platforms to come along with better indexing as we go. So as I also demonstrated, you can add smart columns, which that's my term again. But yeah, here's an example where you might rate the satisfaction from a product reviews table. I always find it interesting when I'm reading reviews that some of the reviews are not about the product, but about the shipping process. So you might want to determine, is this a shipping issue? And if so, you put that in a separate bucket, like to a feedback if the thing arrived broken, if it's a shipping issue. These kinds of insights and analytics are capable now, are able to be done now directly in SQL, where previously this would be almost impossible to infer. All right. I gave some examples of text-to-SQL, but just to recap again, these are questions that would be impossible for a RAG system to answer. So I'm arguing please don't sleep on SQL as an important part of your AI systems. Now, we talked also about MotherDuck has the built-in text-to-SQL support, so you can either use prompt SQL if you want to find out the SQL needed for answering your question, at least the best it can find. And then if you trust it enough, you can just directly run the query that it would create. Again, this is our final architecture. And I want to talk next about like basically the trends that I'm seeing in the space. So I've been basically maintaining a matrix like this for the past year and a half since I first saw the power of RAG and was eager for it to arrive in SQL databases. And the good news is it has arrived in a strong way. Almost all of the mainstream database platforms support vector data types and vector similarity search. Not all support embedding and prompting. And I did some research and I didn't find like really great support for document chunking. So if that's really important to your use case, you might want to use a third-party system to chunk the data before you load it into the database or data lake. But all of these are coming along and it's really exciting to see. I didn't dive into this, but DuckDB has a open prompt extension you can get, which works very similar to what I demoed today in MotherDuck, and which is an open source extension. You can provide your own endpoint, even if that's an internal prompting endpoint, if you want to keep data co-located within your data system, for instance. So lots of great stuff here. And even as I put this on the screen, it could be stale by the time we end this presentation. It's great to see the innovation happening here. I promised that I would give you some warnings. And this is all one big way to say that you have to really understand the performance profile and the cost profile for some of these new superpowers that you might have in the database. So in general, LLM access and embedding compute is getting cheaper and cheaper. And that is how MotherDuck and others are starting to be able to offer these directly in the database. But it still costs something, and it's still going to be more expensive than a traditional like CPU type computation. So whenever you can, do incremental processing. Airbyte is built on incremental processing, so we always try to give you just a new increment of your data and save you costs from loading things you've already seen. You'll want to do a similar thing when you're creating embeddings, maybe when you're performing those inferences, and just store your query somewhere. You don't want to necessarily rerun that prompting every time you run a select statement. So store it either in a new column or a new table so that you don't pay that cost each time you run it. Always plan that you occasionally need to fully restate it if some logic changes, so just design that way. dbt is great for that. dbt is actually harder for the incremental piece, but there are ways to do this in dbt if you're dbt users. Yeah, so the last one I want to lead you with is expect changes. This is a brand new capability in SQL databases, and I'm excited to see how the space evolves. I know that the best practices will change over the next 2 years. For instance, what if the database is caching the vectors and maybe you could rerun it without paying that additional cost? So the things that I can't predict in terms of how the industry will change, and I'm just excited to watch it. But do be prepared for change if you dive in here.